Hello, everyone. Hello, it's Mr. Shield here. Hello. It's time for our second lesson about volcanoes. Our second lesson, lesson number 2. So we're on to volcanoes number 2. We're going to talk a little bit about volcanoes erupting today. So in this lesson, we are going to, revise our learning about the structure of Earth that we did last time around. We're going to learn what happens when a volcano erupts, and we're going to create a diagram of an eruption and a volcano. All right. Now, to do this lesson, you're going to need the sheet. Hopefully, you'll be able to see it on the screen. And it's got kind of 4 sections to it. All right. And we'll come to each section. I'll tell you to pause. You know how it works by now. You're experienced people at this. Well, let's get cracking then. Let's get straight into revising about the structure of the Earth. In this first box on our sheet, let's try to add the layers of the Earth if you can remember them. Do you remember them from last time? We talked about what's the layer on the outside of the Earth begins with a C, and then the layer just underneath begins with an M, and in between that we've got an inner and an outer, or an outer and an inner. Can you remember what they were called? Pause right now and try filling out the little box there. You can colour it in as well, make it look good. That's important. I like it when the sheets look good. So colour them in. Label the layers of the Earth, pause, and when you're done, I'll see if you're right. Okay, let's have a go. Let's double check now. Pause and unpause when you're ready to check. Here we go. Let's see if you got them right. There we go. The outside layer of the Earth, that's the crust. There we go. The layer just underneath that, the mantle. You remember that? The mantle. And some people like to describe an upper mantle and a lower mantle. And the mantle is sometimes liquid and sometimes solid. But if it gets really hot, it can get liquidy. Okay? An outer core, which is a liquid layer of the Earth, and an inner core, which is the solid, most central middle layer of the Earth. And both the inner core and the outer core are made from one material. Iron. We learned about that last week as well. So I hope you did that all right. The next bit I wanted to revise was these 3 questions. See if you can write them down. I'll read them to you now. What is the name of the layer in between the crust and the core? So you might need to check your diagram to work that one out. What happens to the substances in the mantle when they get really hot? What happens to them? What happens to the substances in the mantle when they get really hot? I might have told you just a few seconds ago. Have a good think. And how hot does the inner core get? Can you remember? It's hotter than a regular oven. Okay, have a think about that. It was really hot, really hot. We're thinking more than hundreds. Okay, that's a little clip for you. So pause there, see if you can write in the answers to those questions, and we'll double check them in 5 seconds. All right. Let's have a look. Right. The layer in between the crust and the core is the mantle. It's the mantle. And what happens to the substances in the mantle when they get really hot? Or when they get really hot, the mantle, those substances can become liquid. All right. We'll talk about that liquid in just a minute. How hot does the inner core get? 5,500 degrees Celsius, which is amazingly hot. You'd burn a pizza in less than a second, I tell you what, if you had an oven that got that hot. Anyway, right, let's move on. Let's get to it. Now, there's a word that's going to come up today, and I just wanted to bring it out, show you it, and talk about it, because then when you see it later, you'll be like, aha, remember that. And this word is viscous. Viscous. Have a go at saying that at home. Let's hear you. Yeah, not bad. All right, yeah, you're getting it. Viscous. Now, when something's viscous, it means that it's a substance that's thick and sticky, all right? We can call that a viscous substance. It could also be said to be kind of halfway in between a liquid and a solid, all right? If you can think of any liquids that are kind of halfway in between a liquid and a solid, you could say that was viscous, okay? Look out for that. That word is going to appear later, all right? Anyway, let's move on. Have a look at the image on your screen now. What can you see? All right. You might call it lava or magma, and we'll talk about what it is in just a second. really, I wanted you to know that when melted rock in the mantle, that second layer of the earth, gets really hot and the earth's crust is really thin, the melted rock might burst through from up the mantle, through the crust, okay, and out onto the top of the crust where we live. And where that happens, we call it a volcano, okay? And we say that the volcano is erupting, okay? Now, when this liquid rock gets really hot, we sometimes call it molten rock, because it's hot liquid rock and it's molten rock. Now, when that molten rock is below ground, we actually call it magma. Magma, when it's underneath the ground, that hot liquid rock is called magma. But when it comes above ground, out onto the top surface of the crust, we call it lava. So it goes from magma below ground, up and out, and then we call it lava, okay? Now, this image shows Mount Etna, which is a volcano in Sicily, an island just off of Italy. Mount Etna is erupting, and if you can see on this image, look at the amount of lava that is pouring out of Mount Etna. Again, let's remember that lava is just molten rock, and we call it lava because it's above ground. Look at it, there's loads of it, it's like an ocean. Don't swim in there though, don't swim in there. Oh, I wouldn't do that, that'd be a bad idea. Right, now, let's think about what we've just learnt so far. I've got some sentences on your sheet and I want you to try and fit in some of these words that we've got. And the words are magma, lava, molten, erupting, volcano, thin, and mantle. I'll read the sentences out to you now so you can hear them in your head and you can read them along if you like. Right. When molten rock in the somewhere gets very hot and the Earth's crust is very something, the melted rock might burst through the crust. Where this happens, we call it a something. We say that the volcano is doing something. What's it doing? Have a look. What word can you use? Liquid rock is sometimes called something rock. All right, see what word fits down there. And when this molten rock is above ground, well, the answer's there, isn't it? Never mind. When the molten rock is above ground, we call it something. What could it be? And when molten rock is below ground, we call it something else. What could it be? Make your decision. If you're not sure, you can always rewind the video. You can, bit of a cheeky rewind, have a look. I won't mind. I won't. It doesn't matter to me, as long as you're getting it right. That's the important thing. All right, pause there. Have a go at writing in your answers. And when you're ready in like 5 seconds, you can press play again. Right, I'll count down. 4, 3, 2, here we go. Now, this photograph was taken near a volcano called Kilauea, okay? Mount Kilauea in Hawaii. And I Googled how to pronounce that, so I hope I've got it right. Now, Mount Kilauea has just erupted, and the hot molten rock is flowing very fast. Can you see it on the street there? Now, do we call this molten rock, do we call it lava? Or do we call it magma? Do you remember what we call it when it's above ground and what we call it when it's below ground? This hot molten rock. My goodness. Have a think. It's quite a cool picture, this. I really like it. Look, can you see some of the details in this image? Look how it set fire to some of the cables along the street. And even if you look in the distance, you can see fire just jumping out and setting fire to trees. That's how hot this molten rock above ground is. But is it lava or magma? What's that? Sorry, I didn't quite catch it. You're right, it is lava. Yes, absolutely, good answer. It's lava because it's above ground. What about this? Have a look at this. Now, this is the side of a volcano. And this isn't just regular soil, but have a think. Is this hot lava? Is it cooled lava? Cooled lava that's cooled down? Or is it magma? Have a think. What do you think? Ooh, it's very crackly and rocky and ooh, hot lava, cooled lava, or magma. Do you think it's still hot? Maybe it's cooled down, or maybe it's underground. What do you think? Well, I can see a sky there, so I don't think it's below ground, so it's not magma. And it's not kind of on fire and all red and hot looking, so it's probably not hot lava, which means, yes, absolutely, it's cooled lava. Good job, you. You're really clever. Right, now, have a look at this one. Hot lava, cooled lava, or magma? We saw this image earlier, didn't we? Well, this is actually an image of Mount Etna erupting, and down the side of Mount Etna is pouring this rather boiling hot looking stuff. So let's rule out cooled lava because we can see it's hot. Now it's above ground, so it's not magma, is it? So that must mean it's hot lava. Hot lava! Don't go swimming in there. Whew, be dangerous. Right, okay. Let's move on. Hot lava, cooled lava, or magma? This is the side of a shield volcano, which is a type of volcano. We'll talk about a little bit later, by the way. Is it hot lava, cooled lava, or magma? That's right. Well done, you. It's cooled lava. It was once hot when it came out of the volcano. It's cooled down and stopped being runny and solidified. It's turned into sort of like a solid cooled lava and added an extra layer on top of that volcano. We'll talk about that as well. Now, over the past 100 years or so, geographers and scientists have found out how the magma forms. And magma collects underneath the crust in things that we call magma chambers. Now, this magma chamber that you can see in front of you is like a large pool of that liquid molten rock beneath the surface of the earth. And sometimes different magma chambers can be connected. And you can see little lines of magma running down from our diagram. Can you see it in the picture? And you can see this vent that goes up. We'll talk a little bit about what the vent is in just a second. All right, so the magma chamber. The magma chamber is really important. It's a big deal in learning about volcanoes. It's this large pool of liquid molten rock underneath the earth. Now, remember viscous? A substance that is thick and sticky can be said to be viscous. Okay, let's learn about viscous liquid. Now, lava actually can be thin and runny, or it can be thick and sticky. Viscous, there it is, there's the word. So lava can be thin and runny, or it can be quite viscous, which means it's thick and sticky. Viscous lava, right, causes more explosive eruptions. This is because the gases that are kind of building up and shooting the magma up the volcano have to work extra hard, so the pressure builds up, and then the gases escape violently, blowing this thick viscous lava up into the sky. Now, some eruptions can be quite gentle. So Mount Kilauea in Hawaii has been steadily pouring out quite thin, runny lava ever since 1983. So on and off for almost 40 years. Mount Kilauea's runny lava poses very little threat to humans because, well, it's quite thin and runny and slow as an eruption goes. And you can actually get away from it pretty quickly because you know where it's going and it's been erupting steadily. So it's not a surprise. So you can fence off the areas where it is. Now, let's just recap. Why do volcanoes erupt? So the most important thing to remember really is that volcanoes erupt because of a big buildup of pressure underneath the ground. And that pressure starts building up inside the magma chamber. And it builds and builds because all of these gases push the magma up and it's got to find somewhere to go. The magma moves upwards, sometimes very fast, and erupts from gaps in parts of the Earth's crust. And we call those gaps volcanoes. And we say they're erupting when that pressure from under the ground has pushed the magma up. All right, let's look at a diagram so we can see what's happening. This shows how the magma flows up to the surface through what we call a vent. So you can see from this diagram just how dangerous a volcano can be. Let's have a look. I might draw a little bit here. So we can see the magma chamber down the bottom, and we can see this sort of line called the main vent where the magma is pushed upwards. If the pressure in the magma chamber really builds up, the magma has nowhere to go other than up towards the surface. And it shoots upwards in a violent rush, going through this main vent, or maybe a secondary vent as well, if there's more than one pathway for that magma to shoot upwards. So it's all about those pathways out of the Earth's crust. And then shooting out at the top, or the secondary vent there as well. There might be loads of vents depending on the type of volcano. And it all shoots out in this eruption. And we get the lava flow coming down, up into the sky and down the sides of the volcano, a huge cloud of ash and dust, and some of the sort of dried, cooled lava that might have been blocking the path gets shot upwards as well. Some of the hot magma will shoot into the sky as well in sort of thick, viscous clumps, and then it cools down in the air and solidifies in the air and then drops down as something called volcanic bombs. Watch out! Volcanic bombs are dropping from the sky, and they're really dangerous. So that's quite a cool diagram, this, isn't it? We've got the magma chamber, we've got the vents, we've got the ash cloud, we've got these dots with volcanic bombs in and ash, and we've got the lava flowing down the side. All right, now on your sheet, in just a minute, we're going to make a diagram of this volcano, and we'll look a little bit more in more detail in just a minute. So I'm going to come back to this slide, and you can pause it and kind of draw your diagram as well. But before we do that, I just wanted to tell you the types of volcanoes, because we're going to look at that in more depth next week. Actually, next week, when you're back in school, fingers crossed. Right, let's have a look. There are different types of volcanoes, all right? And we classify volcanoes by their shape. So the most common shapes are composite volcanoes and something we call shield volcanoes. Not shield volcanoes, not named after me, shield with a D on the end. Composite volcanoes, which are the ones you can kind of see on the left here, are sort of steep-sided, look a bit more like mountainous shapes, and they're made up of layers and layers of ash and viscous lava that have shot out, cooled down, and kind of made them steeper and steeper over time. Shield volcanoes have kind of gentle sliding slopes and runny lava. Okay, gases escape very easily from shield volcanoes, and this means that that pressure doesn't build up as much, and they're not often as explosive as a composite volcano. All right, so that's composite, steep-sided, shields, kind of a bit more gently sloping. And then the other one I want to show you, super volcanoes. Super volcanoes. Not a superhero who's also a volcano, but a super volcano, because it's enormous. Now, the third type of volcano, it's quite rare, this super volcano. They're enormous and are highly explosive. Highly explosive. No one alive has ever seen a supervolcano erupt, okay? Geographers and scientists have worked out that the last supervolcano eruption was about 2,700 years ago in New Zealand. So no one alive, no one's that old, are they? I don't think so. No one's that old. So no one alive has ever seen a supervolcano erupt. But my goodness, they're enormous. There's no sense of if it would happen soon, but it's been a long time since the last one happened, a super volcano. Right, let's go back and look at this diagram I really wanted you to have a look at. Now, on your sheet, what you've got are the labels that go with this diagram, things that say like main vent and magma chamber. And what I want you to do is underneath those labels, I want you to draw this diagram and then connect the labels up to the right place in your diagram. And I'd like you to use colours so it looks dead good. That's what I want you to do. Use colours so we can see the colour of the magma and the colour of the lava and then the colour of the ash cloud. All right, so let's just look at this again. So we've got the magma chamber down the bottom, that sort of large pool of molten rock. And then we need a pathway, a main vent for it to shoot upwards. And you can even include like a secondary vent where it might go off on a separate pathway and lava could shoot out the top there. Okay. We've also got the crater, which is the hole at the top of the volcano. We've got the ash cloud drifting away there, lots of dust and ash and things that might choke you if you were stood around it. And you can draw some volcanic bombs. Do you remember them? We talked about volcanic bombs. Watch out, volcanic bombs! No, it's fine. Right, volcanic bombs. Do you remember what we said? When lava shoots up really high into the sky, some thick, viscous lava shoots out high into the sky. Sometimes it solidifies in the air, cools down and becomes hard rock-like lava. And that can drop to the earth and cause massive destruction, actually. You've got to be careful, all right, around a volcano for those volcanic bombs. And obviously, you know, the burning hot lava, the choking ash, because there's loads of stuff to worry about with volcanoes. If you're stood by an erupting volcano, you need to get out of town, okay? Get out of town. Right, where were we? Right, yes, diagram. So, pause here, have a go at making your diagram look beautiful, look accurate, make sure you label everything correctly, and then have a really nice time drawing it. I like drawing volcanoes, it's fun. Apart from that, well done you did really well today. Hey, keep going. Couple more days left of remote learning and then we're going to be back in school and that's awesome. Right, bye-bye from me. Take care.